Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all the students of class 11 for our chemistry lecture. Hope you all will be fine and safe. Today student we are going to start the new chapter, that is your chapter number 9, elements of group 13, 14 and 15. This is our first lecture for the same. As introduction part has been deleted for the current year 2020-21, a little bit we are going to study regarding the introduction. As we have learned in chapter number 7 in modern periodic table that p block elements are those elements in which the differentiating electrons, means the last filling electrons, enter the outermost p orbital. Here the elements in which the differentiating electron enter the p orbital, that elements belongs to p block. Fine. We also has known that maximum 6 electron can be accommodated in p subshell, that is 3p orbital, px, py, pz. This give rise to 6 group, starting from group 13 to group 18, which are your p block elements. Group 13 to group 18 in the modern periodic table, that is your p block element. The p block element shows greater variation in the properties than s block, which we have studied in the previous chapter, that is your chapter number 8. Student, we have studied chapter number 7, chapter number 8. Before moving to this chapter, you're supposed to study chapter number 7 very well. We have studied each and everything in our previous chapter in detail. Today, in this chapter, we are going to study the elements of the group 13, group 14 and group 15 in details. As we know that group 13, group 14 and group 15 belongs to p block elements. Here the elements boron, aluminium, gallium, indium and thallium. These elements constitute the group 13, which is also known as boron family. Here which elements are present in boron family? Boron, aluminium, gallium, indium and thallium. I am repeating it again student. Boron, aluminium, gallium, indium and thallium. These 5 elements constitute group 13 and they are known as boron family. The elements carbon, silicon, germanium, tin and lead, these form the group 14 and they are also known as carbon family. Which are the elements are present in group 14? Carbon, silicon, germanium, tin and lead. Fine student. And the elements nitrogen, phosphorus, arsenic, antimony and bismuth, these elements belongs to group 15 of the modern periodic table. They are also known as nitrogen family. So here student, boron, aluminium, gallium, indium and thallium. Repeat it again student. Boron, aluminium, gallium, indium and thallium, 5 elements, they constitute the group 13 and known as boron family. While carbon, silicon, germanium, tin, lead, they form the group 14 and known as carbon family. Element nitrogen, phosphorus, arsenic, Antimony and bismuth belong to group 15. They are also known as nitrogen family. So here student, we are moving forward towards that whatever we have studied now, that is little bit introduction regarding the chapter, as introduction has been removed from the syllabus for the current year. So a little bit introduction we have studied about the chapter, about the group 13, 14 and 15. We are moving forward towards electronic configuration of elements of group 13, 14 and 15. So here, group 13, boron family. Element boron, its atomic number is 5. Here student, we are writing down the condensed electronic configuration. I have explained in detail about electronic configuration and condensed electronic configuration in modern periodic table. In detail we have studied of principle, how to write down the electronic configuration of the elements, each and everything we have studied in detail. So here student, the element boron family, first element is your boron, whose atomic number is 5 and whose electronic configuration helium. Here 2 electron has been done. Okay, helium 2s2 2p1, 2 electron for helium, 2s2, here 2 plus 1 2 plus 2 plus 1 5. Okay, so condensed electronic configuration is for boron is helium 2s2 2p1, while for the next element, that is your aluminium, whose atomic number is 13, its condensed electronic configuration is neon 3s2 3p1, neon 3s2 3p1. Fine. Now for gallium, whose atomic number is 31, its condensed electronic configuration is argon 3d10 4s2 4p1. Then indium, whose atomic number is 49, its condensed electronic configuration is krypton 4d10 5s2 5p1. Then titanium, whose atomic number is 81, its condensed electronic configuration is xenon 4f14 5d10 6s2 6p1. These are the condensed electronic configuration of boron family. Student, you're supposed to be very expert now, because we have studied modern periodic table, chapter number 7 and chapter number 8, elements of group 1 and 2. In modern periodic table, we have studied each and everything in detail. You are supposed to be very expert in writing down the electronic configuration of any of the element. From these boron family condensed electronic configuration, what we are observing, that the last electron, that is the differentiating electron, enter in the p orbital. So here the last electron in each of the elements enter in p orbital, and it consists of one electron. Okay, so it's is the electronic configuration, that is the condensed electronic configuration of boron family. Let's move forward towards the condensed electronic configuration of group 14, that is of carbon family. Here these are the 5 elements: carbon, silicon, germanium, tin and lead. Now atomic number for carbon is 6. Its condensed electronic configuration is helium 2s2 2p2, helium 2s2 2p2. Then silicon, atomic number 14, its condensed electronic configuration is neon 3s2 3p2, neon 3s2 3p2. Then germanium, whose atomic number is 32, its condensed electronic configuration is argon 3d10 4s2 4p2. I'm repeating it again. Germanium, atomic number 32, Its condensed electronic configuration is argon 3d10 4s2 4p2. Then Sn, that is your tin, whose atomic number is 50. Its condensed electronic configuration is krypton 4d10 5s2 5p2. Krypton 4d10 5s2 5p2. Then the element lead Pb, its symbol is Pb, whose atomic number is 82. Its condensed electronic configuration is xenon 4f14 5d10 6x2 6p2. You are supposed to know the atomic number. On the basis of atomic number, we are writing down the electronic configuration. So here in this, the last electron, that is a differentiating electron, enter in the p orbital. It consists of 2 electrons. Okay, as it belongs to group 14, that is the second group from the p block. Group 13 is the first group from the p block. Group 14 is the second group from the p block. So here this is the condensed electronic configuration of group 14, that is your carbon family. Let's move forward towards the group 15, that is your nitrogen family. It consists of 5 elements: nitrogen, phosphorus, arsenic, antimony and bismuth. So here atomic number for nitrogen is 7. Its condensed electronic configuration is helium 2s2 2p3. I am repeating it again: helium 2s2 2p3. Then phosphorus, symbol is P, atomic number is 15. Its condensed electronic configuration is neon 3s2 3p3. Neon 3s2 3p3. Then arsenic, symbol is As. Its atomic number is 33. Its condensed electronic configuration is Ar, argon 3d10 4s2 4p3. Argon 3d10 4s2 4p3. Then antimony, whose symbol is Sb and atomic number is 51. Its condensed electronic configuration is krypton 4d10 5s2 5p3. Krypton 4d10 5s2 5p3. Then the last elements of group 15, that is your bismuth, whose symbol is Pi and atomic number is 83, whose condensed electronic configuration is xenon 4f14 5d10 6x2 6p3. Xenon 4f14 5d10 6s2 6p3. Here student, the last, that is your differentiating electron, enter in the p orbital, and it consists of 3 electrons in outermost p orbital, as this is the third group from the p block element. Okay, so here student, we have studied about the elements of group 13 14 15. Which are that elements? What is its atomic number? What is its electronic configuration? You are supposed to know the elements of group 13, group 14 and group 15. Let's take a revise on it. The elements from group 13 is your boron, whose atomic number is 5, whose symbol is B. Then the next element from the boron family is aluminium, whose atomic number is 13, whose symbol is Al. Next one, gallium, atomic number is 31, whose symbol is Ga. Then indium, whose atomic number is 49 and symbol is In. Then the last element from the boron family is thallium, whose atomic number is 81 and symbol is Tl. Then from the group 14, that is from carbon family, the elements carbon, atomic number 6, symbol is C. Then silicon, atomic number is 14, symbol is Si. Then germanium, atomic number is 32, symbol is Ge. Then tin, atomic number 50, symbol is Sn. Then lead, atomic number 82, symbol is Pp. And the group 15 element is nitrogen, that is from the nitrogen family. Nitrogen, whose atomic number is 7. Phosphorus, atomic number is 15. Arsenic, atomic number is 33, symbol is As. For nitrogen, symbol is N. For phosphorus, it is P. Then for arsenic, As. Then for antimony, atomic number is 51, symbol is Sb. Then finally your bismuth, atomic number 83, symbol is Pi. So your student, we have studied and little bit introduction regarding the chapter, that is your elements of group 13, group 14 and group 15. So your student, you're supposed to know that these group 13, group 14 and group 15 belongs to p block element. Why they are belongs to p block element? Because the last, that is a differentiating electron, enter in the p orbital. You're supposed, we have studied this thing in today's lecture, so you are supposed to know the answer of these question, that elements group 13, group 14 and group 15 belongs to which block and why they are belonging to that particular block. And group 13 consists of how many elements? State the elements with its atomic number with its electronic configuration for group 13, group 14 as well as group 15. Take a book, take a pen, write down the answer of this question which I have stated right now. I am repeating the question again. Note down the question, write down the answer, student. The question is, group 13, group 14 and group 15 belongs to which group and which group? Sorry, group 13, group 14 and group 15 elements belongs to which block and why? Fine, this is our first question. The next question, group 13 elements is also known as dash. Group 14 elements is also known as dash. Group 15 elements is also known as dash. State the elements, next question, state the elements of group 13. State the elements of group 14. State the elements of group 15. The next question, write down the atomic number as well as its electronic configuration of group 13 elements, group 14 elements and group 15 elements. If you are able to write down the answer of these questions, it means you have done this lecture very well. You have completed the lecture, you have done very well. Take a pen, write down on the notebook. Study well, student. Take care. Till then, Allah Hafiz. Thank you, student.